Right, so good afternoon and welcome to the NEBOSH Process Safety Management course. We are on chapter 3 today. We're going to get into these learning outcomes here. Explain the purpose and requirements of standard operating procedures. Outline the controls that should be adopted to control the safe startup and shutdown of process plant. Outline the necessity for performance standards and for safety critical systems and equipment and the concept of FASI. I don't expect us to get into steam, outline the hazards and controls associated with use of steam and water within the process industry. If we get into that, I'll be very happy, right? And so what we can do, if you all remember, we could read a bit and explain. Again, each of these have questions in them, right? So, but the thing is, not every word on the screen then, is a word for an exam. Like the word on the screen is ready for development of the lesson itself. But if we can explain a bit, and you all know we normally go faster. If there's something directly on the screen for exam, I'll let you all know that as well. Such as when we had done the PDCA cycle, right? Let's get into this. So, safe operating envelope. The safe operating envelope refers to the set of limits and conditions within which the process operation must be operated to ensure conformance with the safety analysis upon which the process plant operates, which can be monitored by or on behalf of the operator, technician, or supervisor. Parameters that contain a control reaction with prescribed upper and lower limits enabling safe operation. I wonder if it's too early to explain, but to be honest, this is a passive question, right? And it's the first slide anyway, but they have asked what is the safe operating envelope? And you kind of want to go with something like the last point here, which is the safe operating envelope would have like a lower limit and an upper limit, right? And so if I was to explain it, and I know it's too early for explanation because we now start, but if I was to explain it, if you think about something like your propane tank at home, your gas tank at home, right? There would be like there'll be like what is called like a lower limit, and I'll just put L there, and there'll be like an upper limit. If that tank had a leak in it, then I mean, God forbid anyway, right? So what you want to do, you kind of want to steer away from that. You kind of want to steer away from that range then, right? So the safe operating envelope will kind of be out of that range. But if I guess if we take it out of the kitchen, because the propane tank is a kitchen example. Like if you're working in a plant then, right? Let's say working, those of us from Trinidad, we do have some gas plants around, we have some ammonia plants around, right? And it's just an example anyway, right? So if you are working in an atmosphere that has some kind of gas, it doesn't have to be ammonia, but Trinidad has ammonia, right? What they're saying is that the safe operating envelope then, right, will contain a reaction with prescribed upper and lower limits enabling safe operation. So if you could take this one down, because I actually know this one, right? I think for ammonia, the lower limit is 18 milligram per meter cube, and the upper limit is 25 milligram per meter cube of ammonia in the air that somebody can breathe in, right? So the question is, where would be safe then? Where would be safe, right? And that's just an explanation because the truth is, I think for multiple choice, they may just say something with an upper limit and a lower limit. So the one that you see has an upper and a lower limit, then that's the answer. But in reality, if you could answer, like, where would be safe if you are the operator working on a plant? I'm using ammonia as the gas here, right? But like where would be seen to be safe? If you had to guess. Now, this is a number line, so I mean, we can actually extend the line here, right? But if you're counting then, like 1, 2, 3, 4, 5 to 25, when you reach 18, then you reach the lower limit of ammonia in the atmosphere that is tolerated then. And then if you reach 25, well, if you cross 25, it means the person breathing in more ammonia than they should be breathing in. So the thing is, where would be safe? Any answers to that?
Papa, You always have to go upwind.
Upward. But okay, upward. But
Around around 2021.
around
Um,
2021. Okay. Anybody else?
Would it be between the two ranges to be safely operating?
Yeah, it would be safe because that's a safe operating envelope. But I'm trying to think how tricky Nibosh can be, right? So let me rephrase my question, but they wouldn't rephrase the question and they will ask the same question. Like, yeah, I mean, within the safe operating envelope, fine, right? But where would be safer then? Where is the safest range to be at? But picture this as a number line. I didn't draw all the numbers though. So we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 25. Where would be safe? So not for the passive, because the passive is upper and lower, and upper and lower is the answer. But in reality, if you was working on a plant and it had this gas in the atmosphere, 18 milligram is like the figure that could affect a person, but it's the lower end of it. And then 25 will cause some effects on the person. So where would be the safe range to have the worker operate at? Like what concentration? And because this referred to milligram per meter cubic, where would be the safe concentration for the person to be breathing in?
18 and under.
18 and under, right? So let's take, because I remember in a passive, but because they could give you 18. But what if they give you 15? 15 is actually safer because you're out of the range there, right? This is just a reality question though. It's not it may be a passive, but really and truly, if they ask safe operating envelope, what you're looking for is this here. The answers are all, parameters that contain a control reaction within upper and lower limits. I don't know if you want to kind of draw the scale down. Initially, this is the passive question here, lower and upper limits, right? I was just thinking of, in reality, if somebody was exposed to 18, well, that's a safe figure. This published by the law and stuff, right? There's a law for this, it's called COSH. But if somebody was exposed to 15, 15 is actually safer than 18. So the lower the figures, the better then, right? Just in terms of reality on a plant, if you measure and you get 10 milligram per meter cube, but that's better because it's safer for the worker then because at these figures, there can be some effects to the workers anyway. If you want just kind of have an idea of this, but also have an idea of the past paper, which is what I kind of underline here. What is a safe operating envelope? It's like parameters that have an upper limit and a lower limit, right? So L for lower, U for upper. But in reality, I was saying you could actually go lower than the lower limit. That's what I'm trying to say. You could go lower than the lower limit and it could still be safer than the prescribed laws that say ammonia is supposed to be 18 and 25. By the way, these are real figures. That is actually the limit for ammonia in any plant, 18 milligram per meter cube and 25 milligram per meter cube. Those of us in Trinidad, though, those of us who are familiar with the plants, I wouldn't call them by name because, we have actually more than one. But there is one, but then there's a lot of knockdown plants as well. You know, um, it's kind of hard not to say their name if you're from Trinidad, right? But those pro plants, man, right? But do you know the ammonia concentration in those plants is way above these? The ammonia concentration in Trinidad in the plants that I've just called is way above anything you can see here. It's way above it. I know for a fact, a dead fact. Yeah, a dead fact, right? Yeah, Lisa?
Sorry, I know Join, sorry.
Okay, sorry. Yeah, yeah. Yeah, a dead fact. I know of some workers that got cancers and stuff coming out of that plant. Young people in their 40s, I would say, right? And passed away after being exposed to ammonia. And that just, I know of other instances, not deaths, but I know of one death, right? So anyway, I'll take that off there, right?
So my question is, why is that allowed?
Because we don't have any laws. We don't have a law. Like the law I mentioned is a law from England. It's not a law in Trinidad. It's not a law. Well, Guyana doesn't really have ammonia, but it's not allowed. It's not a law here then. So the 18 and the 25, the company will try to maintain it, but it's above that. It's above that anyway. I tell you, I know of a worker that, anyway, lump say, I mean, felt a lump, got it checked out after working a couple of years and the plant turned out to be cancer. It turned out to be the bad kind of cancer. Then there's actually a good kind. When I say a good kind, cancer is never good, but there's a kind that you could operate on and take it out. Like if it's a lump, right? It's called benign. His own wasn't benign, it was malignant, meaning it spread. And in less than 6 months' time, he passed away. Right? So, but no laws is the answer for that, right? No laws is the answer for it. Anyway, that's a bit of reality. That's the first slide. We shouldn't spend so much time on the first slide. But the reason why I stop on the first slide, really, the first couple of slides, because this bottom part here is a passive question. What is a SOE? What is the safe operating envelope? Have a lower and an upper limit anyway. All right, I'm moving on. And as I mentioned, I would do some mass explanation other than that one. So I'll read a couple first, right? And then I'll kind of sum it up. So operating procedures are written instructions, including procedures that are stored electronically and printed on demand that list the steps for a given task and describe the manner in which the task are to be performed. Good procedures also describe the process, hazards, tools, protective equipment, and controls in sufficient detail that operators understand the hazards, they can verify that controls are in place, and they can confirm that the process responds in an expected manner. Operating procedures are normally used to control activities such as transition between products, periodic cleaning of process equipment, preparing equipment for certain maintenance activities and other activities routinely performed by operators. Operating procedures can describe the tasks required to safely start up a plant, operate the plant, shut down processes, including emergency shutdown. Operating procedures, the purpose to ensure a consistent high level of human performance in a safety management program, to enable assurance that the intended procedure and methods are used by each operator, or even that an individual operator will consistently execute a particular task in the intended manner. So just a long story short, I mean, I think it's self-explanatory. They basically said anything you do in a company will have a procedure. And if you follow the procedure, but then you'll be consistent. Like you wouldn't be doing your own thing, right? If you want to start up a plant, there'll be a procedure for that. You want to start up a machine, there'll be a procedure for that. So just follow the procedure, right? So the rest of actually this slide is talking about how they write it. And I don't think this is an exam question, but it's content anyway, right? I'll read a couple and I'll explain after a couple of slides and move on, right? So procedures are often jointly developed by operators and process engineers who have a high degree of involvement and knowledge of process operations. Operators, supervisors, engineers, technicians, and managers are often involved in the review and approval of new procedures or changes to existing procedures. Who should be involved? Operating procedures, right? Other work groups such as maintenance should also be involved if the operating procedures could potentially affect them. At some facilities, technical writers are used to translate what is being said, the input from subject matter experts, such as experienced operators or engineers, into their operating procedures. I keep on reading, and I don't think this is exam questions here. We covered the exam question already. Procedures should be written in sufficient detail that a qualified worker can consistently and successfully perform the task. It must be simple to understand and readily accessible. It can include a listing of tasks to be performed and its associated hazards during normal operation, non-routine or infrequent tasks, special high hazard tasks, right? Basically, there's a procedure for every type of work activity. And I have a bunch written down here, right? So operating procedures, the content, example, the operating procedures addressing operating parameters will contain operating instructions about pressure limits, temperature ranges, flow rates. There's a procedure to do when an upset condition occurs. There's a procedure when an alarm or instrument, goes off, if there's an upset condition. There's a procedure for starting up and shutting down. We covered that already. There's a procedure. So operating procedures or operating instructions need to describe the proper method for whatever you're doing, right? Increasing the temperature of a unit, decreasing the temperature of a unit, the safety and health precautions to be taken. Again, the story here is that there's a procedure for everything, right? There's a bunch here again. The operating procedures for starting up your plant, normal operation, temporary operation, emergency shutdown. Yeah, in a plant, in an emergency, the technicians don't, run around shouting, we're going to die. They follow the procedure. If there's an emergency shutdown procedure, close off a valve, turn off a tank, open another valve so the content goes into another tank. They know what they do, right? And if there is a fire, if there is a meltdown, there's also a procedure as to how to get out of that anyway, right? It may be that you head to the safe zone on your platform or your vessel, or you wait for emergency rescue, or in some cases, you try to jump out, which, is not really advised. But they did do that in Piper Alpha, for those who know about that offshore explosion, and you rope yourself down into the water, right? So there is a procedure to say that what is normal operation, what is, not a normal operation, even for emergency rescue, right? So the point is here, in companies, then there's a procedure for everything, right? So it needs to be clearly understood. So I guess I can leave that as a heading there. All operating procedures must be clearly understood by the end user. The heading says it all, right? So if a company has a procedure, they need to train, educate, and probably do a drill with the workers to know that they know what to do in the event of something. If it is an emergency, if it's normal operation, they still need to put them through, that sort of simulation then that they know how to operate the plant, right? And establishing their training programs, employers must clearly identify the employees to be trained, the subjects to be covered, and the goals and objectives they wish to achieve. Employers should describe the important actions and conditions under which the employee will demonstrate competence or knowledge, as well as what is acceptable performance. Hands-on training is, of course, I guess, the best when you want to, find out if your procedure has been understood. Let's see here, for example, operating personnel who will work in a control room or at control panels would benefit from being trained at a simulated control panel. Upset conditions of various types can be displayed on the simulator, and then the employee will go through the proper operating procedures to bring the simulator panel back to the normal operating parameters, right? The procedure should not be needlessly prescriptive. The best way of ensuring that procedures do not become overly prescriptive is through involving the operator during the design stage. Procedures should contain information on the requirement for wearing personal protective equipment during the task. Any risk to the operator should be documented at the start of the procedure based on the risk assessment of the task. An appropriate method of coding each procedure should be used, right? Each time a procedure is produced, it should be dated and also marked where appropriate with a shelf life, i.e. this procedure is only valid for 6 months after the date hereon. There should be no ambiguity, meaning, it's not clear between which procedure applies to which situation. Procedures do not always have to be paper-based, they can be digital. The most important information in the page should be identified and should be designed to be the most prominent information. Separating headings should be used to differentiate clearly between different things on the procedure subtasks. Any warnings, cautions, or notes should be placed immediately prior to the instruction steps to which they refer, right? Language should be kept as simple as possible. When you are writing a procedure, use nomenclature familiar to the operator. I'll explain what that word means in a bit. The nomenclature should be consistent with that on the controls or panels. Symbols, colors, and shapes used by user graphics should conform to the industry standard. Let me just finish up this on the procedure, right? And then and I'll come back because there's really not much stuff there, right? For exam anyways. Of course, remember there's a syllabus, right? So requirement for written procedures, the procedure should not be needlessly prescriptive. I read that already. Read that already, right? Read that already. So the heading here is verification system to ensure that operating procedures remain current and accurate. So usually these systems can include the use of a compliance audit protocol that examines the entire process safety management system. An effective audit includes a review of the relevant documentation and process safety information, inspection of the physical facilities, and interview at all levels of plant personnel. Persons verifying should be competent. Verification of operating procedures to include a means of continual improvement. Same heading. Legal requirement for the employer to certify annually that the operating procedures are current and accurate according to this law is the Control of Major Accident Hazard Regulation 2015. It is an absolute duty denoted by the word shall, meaning the employer shall ensure that the operating procedure is up to date. A procedure should always be formally validated prior to it being issued. The best method to achieve this is a comprehensive walkthrough of what you have in the procedure, or with reference to the relevant plan drawings when and in plant assessment is not possible. The limitations of operating procedures, failure to update when changes are made, such as introduction of new equipment, but they didn't update the procedure to say that. Introduction of new chemicals into the process, the same would be the explanation there. Significant change of process, task, personnel, or equipment covered by the procedure. Plant trials have been successful and need to be incorporated into the operating procedures. If you did some kind of test on your plant and something new came up, you need to update the operating procedure. Otherwise, they may be following the procedure and it may not be all that relevant, right? So there is a potential for an accidental release. This in turn creates the possibility of a disaster. So if operating procedures are not followed, you could have a consequence, right? Recent major disasters include 1984 Bhopal, India. Incident resulted in more than 2,000 deaths. The October 1989 Phillips Petroleum Company, Pasadena, Texas incident resulted in 23 deaths and 132 injuries. The July 90 BASF Cincinnati, Ohio incident resulted in 2 deaths, and the May 1991 IMC Stillerton LA incident resulted in 8 deaths and 128 injuries, right? So that's one word to explain the whole thing about operating procedures. They were saying, just to summarize it, to make life short for you, is that there's an operating procedure for anything that you do in a company. I'd want to say, even if you're not in process safety, like if you had to take a day off, you had to follow a procedure for that. If you were coming back from a sick day, well, you had to submit a medical, so there's a procedure for that, right? But in terms of process safety, that if there's a, like if you have to drain a tank, if you have to empty a tank, right? So there's a procedure for that. I'm not going to go too much into it, right? But you know, you have to isolate all of your inlet valves. You may have to have the contents of that tank trucked out of the tank if it's oil or water. This is really process safety. So it can be anything, right? And the sludge in the tank, all of those things have to be removed by contractors. So all of that are different processes. Then finally, the tank may have to be bled, as they say. You have to open some drain valves and get whatever residue is out of there, right? So there's a procedure then. You just cannot just open the tank and run inside the tank. The tank is going to be filled with something, right? So there's a procedure for everything. There's going to be a permit. There's going to be emergency rescue, gas testing, you know, competent person, contractors, etc. So everything have a procedure. And what they were trying to say was that try to keep it simple as possible. Make sure everybody's involved. If you write your procedure, then have the workers, you know, go through it. If you can do a simulation or a drill, fine. It might be applicable for contractors, but a contractor may have what is called a safe, like a method statement then. So they can actually lay out like what they're going to do. And I'm going to use a tank example here, right? So they got to lay out what they have to do, and that would be like the safe operating procedures. Some of the big words you saw to the end were not really big words anyway. They were just saying the word nomenclature means the culture of the day. Nomenclature means the culture of the day. So if you're writing a procedure for a vessel in Guyana, you're probably going to have to use the words that the workers are accustomed to, right? Whatever slang they have, if you want to do the same in Trinidad, you have to use the nomenclature that familiar to the operator, right? Um, so for those of us, I mean, we could ask because I have two Guyanese here. Like, is there any word that you all say in Guyana for like lifting and carrying something? Like if you have to lift, so you have to lift the hose or lift the bucket and carry the bucket, let's say to the end of the hose. Is there like a word that you all say for that? Trinidad has a word we say instead of lifted. So this would be
Depends
for
on who you're speaking to, sir. Some persons would say fetch, and
fetch.
someone
Okay.
would just use the word carry or lift.
Oh, okay. Well, for my Trinidad students here, like what do we say instead of lifted?
You say
Pick it up.
toot.
Yeah, we say tote, right? So that's the nomenclature familiar to Trinidad. You say tote, but like I said, I mean, if you put in the nomenclature, tote, like the hose from the storage room to the base of the compressor, right? So everybody in Trinidad would understand that. But again, somebody around the world wouldn't understand what is meant by tote. But remember, you're writing our procedures for the workers to understand. So you want to kind of use the words that the workers understand, right? So tote, carry, right? So you can use the nomenclature that is familiar to the operator, right? The second point, now I don't want to explain it because to be honest, none of this is exam. There's no exam question here, right? I can't remember one here, but it's all content now, right? So like the second point, and the third point, the nomenclature must be consistent with the controls or panels. So if you wonder, well, what is that all about? Well, the answer is controls can change. I don't know if you all know that. A button, a control button could change. I don't know if you all know this. Do you know that in certain parts of the world then, okay, if you want to put on a light switch, I guess in the Caribbean or South America, which way would you press that switch? If there's a switch to put on a pump, or something, for to drain a tank or whatever, or to fill a tank, which way do you press the switch, up or down, to put it on? That's an easy question.
Up.
Supposed to be up, right? Yeah. But do you know in England is the other way around? That in England, down is on and up is off. It's kind of strange, right? Like to us, that doesn't make sense. But to them, it doesn't make sense. Right? So you just use, if you want to say, okay, turn the switch on by pressing up. Well, that's just the layout of the control. But in different parts of the world, to put it on, you have to press down. And that's how we grew up with up, they grew up with down. Right? I could give you another one, and this is right in the region here. And of course, our prayers are still with Carriacou, which is part of Grenada. But like when I was in Grenada, the electrical sockets. If you say connect or plug in to the sockets, right? In Grenada, you see the same sockets that you're plugging onto here. The normal sockets on the wall in Grenada is 220. An electrical socket, like in the Caribbean, and I guess because I plugged in all the hotels in Guyana as well. Your normal socket supposed to be what? A normal socket like in Trinidad and then in Guyana is what? Is 100 and? Anyone knows? I can put it at 110 volts.
110 volts.
110 volts. But in Grenada, in St. Lucia, in St. Vincent, in England, it's the normal thing is 220. That's strange. I burnt out one of my I had known about it, and that was my first time in Grenada, right? I've done training for them. And I think I was in front of a class and I just forgot. And I put on the laptop, I plug on the laptop and a projector. And as soon as I turned my back, was just smoke. It burnt out, right? Because the normal sockets is 220. So you had it right for the culture and for the language of the day then, right? And for the company that you are in. So that if you say, okay, well, connect to the supply, or turn on the power, for the generator. Well, in your mind, you have to remember, okay, well, it's 220. So what you have to do, you have to have like a step down unit to step this thing down. Otherwise, it's going to damage your unit. right? So written procedures must conform then to the language and to the culture of the day, right? Every company is different. And some countries are also different as well. I was telling someone recently, you'll ever purchase, like when you purchase your phones, right? Or whatever you purchased recently, or maybe you purchased some time ago, you ever notice it have some weird looking plugs in them, like some weird looking, like when you give your phone, like a phone unit or whatever you purchase or your TV, whatever, you ever notice it have one what does work, but it have some kind of weird looking ones? You ever notice those? Like a kind of square one. You ever notice that? Anybody? I may have some wrong, but it might be in this room here. But you all know what I'm talking about, right? You ever notice that it have like a plug that plug into your thing, like a phone charger or whatever, but then there's a weird one. But that weird one is not weird.
Yeah.
It's just weird to us. In England and in Grenada, the round one is weird to them, right? The round one is weird to them, right? You have one for Europe and it have one for England. Like if you're traveling to England, your phone chargers, whatever your computer chargers wouldn't work, right? It cannot work because it's a different connecting plug, right? That's why they give you those, you get like two or three others. But like I said, for somebody across there, to them, they will look at the ones we use and see, well, this is just a weird thing. They'll just throw it away, right? And I had that experience. I had to catch my tail to find a charger in the UK to charge my units because I didn't even know what I was talking about. I had to kind of break it down in a way. I had to say, Lord, how to break it down to them because they didn't know what I was saying. And what I ended up going with, I ended up saying, America, right? So this is England. So America uses another type of like charging ports then or units or plugs. So do you have the one that the American use? Because to tell them Trinidad, for those of us who know Guyana is big, so maybe they know Guyana, but they didn't seem to know anything about Trinidad. So I had to kind of change all of that and not say the Caribbean and say, well, the American people just use a different kind. This is a huge kind of store, like what they call a Lowe's, the hardware in the States, or Courts in the Caribbean here, or who again is very big in the region. Price Mart. It's a huge store. I'm talking to the persons there, to the sale people, and having to tell them, well, I have to get something like what the American use. So that's what I'm saying. Is it nomenclature? If you're writing a procedure, you have to know what you're writing and then who you're writing it for, because different things to us may seem normal, but different things are really different in different parts of the world anyway, right? Anyway, not an exam question. I just wanted to explain that to you, that the point is when you write a written procedure, make sure you write it to the people that you're writing it for. Don't write it and assume then that they know what you're talking about. Break it down, say what you have to say, right? Use the common language of the day. Don't assume like they know certain phrases like tote, um, you know, um, the UK has one, they call it bleak. Like if you want to say something is bad, they would say bleak. Again, we don't really talk like that in the Caribbean region here, but then that's very common for them, right? Very common for us in the region. If we want to say something is bad, we may say some words like what? Like how would we say something is bad in the Caribbean? We may say what? I'll give you a start. So like, the quickest word that comes to my mind is the word dread. Like we would say this is really dread. But a British person, they might not understand that, right? What is another word? Is there some word that you would say if something is bad in Guyana, or another word for Trinidad?
The tour, the to- oh gosh, I can't get the word. Deteriorating state.
Deteriorating. Okay, that's a fairly good one. That's a fairly easy one. But like nomenclature is like a slang then, as I was trying to say, it's like the word dread. Like we would say, like if the tank overflow, that would be very dread. But they would say bleak, right? They would say bleak, instead of dread. But if you put bleak there for a Trinidad person, they may say, well, what is bleak? Like what does bleak mean? Right? But that's the thing about it, right? Kerry and Javier, real bacchanal. Yeah, that's it, right? So you use the words that people are familiar with. Anyway, folks, I did mention there's no exam question there, so but just to understand the content. By the way, that's it there for operating procedures. You notice we had reached the end of it. Reach the end of it here, right? So let's go into the next one. If I was to suggest an exam question, the only thing I could suggest here for exam questions is the first slide, this first one here, what is an operating procedure? And then the other thing is maybe how do you ensure an operating procedure is up to date? The answer is with an audit, if you read this slide here, right? Usually these systems can include the use of a compliance audit protocol that examines the procedure then to see if it's still fit for purpose, right? That could be the only answer there. I don't think there's much questions on operating procedures other than an operating procedures exist for everything. So if we ask, how do you ensure a worker will consistently perform a task? That was here on this slide. And how can you ensure that a worker consistently do the right thing? The answer is with an operating procedure. They follow step 1, step 2, written to their language and to their culture, of course, 3, 4, 5, etc. Right? But really not a difficult question. No need for any big set of studies here as yet, right? So we're moving on. Okay, so the next one we have here, outline the controls that should be adopted. I'll open the book for you just now, right? But if you have your book, you can open it, but I'll make some reference in a bit. Outline the controls that should be adopted to control the safe startup and shutdown of a process plant. So controls that should be adopted to ensure the safe startup and shutdown of a process plant could include planned shutdown, unplanned shutdown, emergency shutdown, stage, and delay. Now, if you have your books, there's a past paper here. So let's try to get it open a bit. Chapter 3, yeah? Chapter 3. So you can find these on page 64. Right? Now, if you want, remember, because it's multiple choice, you have to remember the passage really. Just have to remember what the thing is, right? So what you could do, you could tell me when you're ready, if you found the page 64, and I'll tell you what the question would look like. It's a common question. It comes in every paper. And we can just try to figure it out, right? When I say figure it out, we can try to understand what these words mean here, right? So we taken a kind of, like a exam approach then, right? So the exam question is normally what they do, they describe something happening. And they would say, like, what type of shutdown is that? What type of startup or shutdown is that? Right? So if you want, I could just tell me if you understand that. So they would normally give you, like how the book have, if you look at the book, they have small passages. So they'll give it, like they will describe something and then they will say, well, which type is it? And you have to choose from the 4. So if you want, let's start with plan, but plan is not the most common one, right? Let's go to the book. If you want, you can look at plan. I'll read it for you. Plan, they say this is normal operation where startup or shutdown follow a predetermined sequence to bring the plant up to operating condition and is shut down safely. Planned shutdown is sometimes referred to as a turnaround shutdown. And so they'll just do a quick description. They would say like, there is, by the way, plan is not the most common one. I told you that already, right? But they will say like, this type of operation describes normal startup or normal shutdown. Which best describes this type of shutdown or startup, right? And it will be planned. So folks, I think you understand it's not a hard question. If you go to unplanned in the textbook, this is where shutdown is unexpected from an equipment malfunction, often due to neglect of maintenance, power failure, operator error, or similar unexpected event. Unplanned shutdown may be partial or complete. In any event, this can be a dangerous period as the absence of any plan for such eventualities require close attention to the detail of the shutdown to ensure the plant remains safe, right? They might do all of that. They will just say, this is a shutdown that is unexpected, right? May result from equipment malfunction, power failure, operator error, which best describes. Now, you're only going to get one of these questions on the paper, and I don't know which one, but I can tell you which is the most common one when we finish, right? Emergency. This is a specific type of unplanned shutdown that happens where hazardous situation develop and action is taken either manually or automatically to shut the plant down. So they could just do that. Remember, it's a question. They would say this refers to a specific type of shutdown in which a hazardous situation has developed or is developing. What type of shutdown is this? It'll be emergency. Folks, you think you understand it? Stage, right? So in a stage shutdown, if you want, I can read all of this. It's short anyway. I could tell you too, but as we have the book open, I guess we could read, right? Stage. This is when the startup or shutdown are done in stages. For example, some parts of a large plant, such as catalytic cracking units, may not be quickly shut down safely and may take several days to do so. So that could be it right there. They will say there's a type of shutdown that takes several days. They may have to take off, the inlet feed first, then they may have to allow the vessel to cool, then they will have to drain the tanks. What type of shutdown is that? It'll be a stage shutdown. Folks, I think you understand a bit? Last one, delayed. You all are saying nothing, and you all have all your cameras off, which is not good, healthy conversation for a tertiary level class, right? So delayed shutdown. A delayed shutdown invariably refers to a situation where an issue has been raised, for example, a leaking valve, but an assessment is made that the situation can be controlled until an appropriate full or partial shutdown can be dealt with. So, reading from the book, if a leaking valve is detected some 2 weeks before the plant shut down, then subject to an assessment that can be decided to monitor the leak and take local controls until it can be addressed as part of a full or planned shutdown, right? So see if you get it, because of all of them, I'll tell you the most common one. Anybody want to guess what is the most common one? Now, all have come, right? I mean, there are questions unplanned. There's a question on emergency, right? The most common question is delayed. So if you want to take a note of that. And they use the same example in the book for the past paper, or should I say the future paper. They use the same example in the book, right? They say like, there's a leaking valve, a risk assessment has been done, and it has been realized that the risk is low. So the company have decided to wait 2 weeks until a full shutdown. What best describes this type of shutdown? And the answer is delayed. I've seen that question probably more than 5 times. The others have seen it once, right? Remember, you have to study for this exam. Planned is just normal. Unplanned is unexpected. Emergency is unexpected, but it is going to lead to a hazardous situation, right? Stage is that you shut down your plant or you start up your plant in stages. So if you're filling a tank like a water tank, you can even think of this as water, but we could think of different things, different chemicals. You lock off your valve, the drain valve. Maybe you fill your tank to half to see if it could withstand, and you fill the other half, right? It's done in stages then, right? That's a stage kind of startup or shutdown. Delayed though is where something has happened, but what has happened is not serious, it's not hazardous, right? I'm going to read the book again. So if a leaking valve is detected some 2 weeks before the plant shutdown, then subject to a risk assessment, it can be decided to monitor the leak and take local control actions until it can be addressed as part of the planned shutdown or the full shutdown, right? Again, one last time, the reason why we pause and open the book is because of a past paper, and many past papers are that, right? So if this is your book, but not this one, but if you have your book, right, please underline these types of startup and shutdown, all of them. Planned, unplanned, emergency, delayed, stage. Also, please try to listen back to the video. But you could just use your book, right? I mean, I tell you, it's a past paper. I don't know which one is going to come, but they are going to come, right? Let's move on anyway. We may come across a question before the even is true, but let's see, right? So controls that should be adopted to ensure safe startup. Well, actually, this is another question, right? They can ask, what is a control used to ensure the safe startup? It's right here on page 65, just under delayed. It's something called a PSSR, a pre-startup safety review, right? And so I try to relate to you because remember, not only all in process safety, but like if you have a car and probably for the weekend you had it down Monday, tomorrow, maybe this evening, you could walk around your car bed, check out the tires, check your fluid levels, the water, the oil, the steering fuel, right? The transmission fuel, the steering, I suppose, sorry, the power steering fuel, right? Check it out a bit, put on your lights. And so that's like a pre-startup safety review, right? So the PSSR provides a final checkpoint for new equipment to confirm that all appropriate elements of PSM have been addressed satisfactorily and that the facility is safe to start up. So the same for your car. So you can think of it like that, right? If it's a tank, like I said, if you're gonna put on a tank or to fill a tank with oil or fuel, they want to make sure that they have done that, right? That they have closed off the drain valve. Maybe the level gauge is working, the level gauge is going to prevent the tank from overflowing. If the tank would have been welded, the doors should have been, closed tightly and that would have been tested. So they do all of that. They can actually water test that tank, put water in it to see if it can hold the capacity that they want to put the oil or the fuel in it. Before they put oil and fuel in it, they could water test it. It's called hydrostatic testing. Then they would drain the water, probably ventilate the tank, use a vacuum unit in the tank, whatever, have it to clean that tank. All of that is like your pre-startup safety review, right? So please take a note of that word. PSSR, right, is an answer to a lot of things, right? So before a unit is brought back into service, including your cars, if tomorrow is Monday and you haven't gone anywhere, then you do like a check on it. And that's called, in the process safety world, it's called a pre-startup safety review. All right. All right. So moving on here. So controls that should be adopted to ensure safe startup, visual inspection, if you could, all alarms, strips, and pressure relief valves, make sure they work in order. When required, new plans or changes, full training must be given to the workers or the contractors. Necessity for alarm systems to be in full working operation and designed or designated or designed to alert, inform, or guide the operator, allowing for diagnosis of the problem. Alarm systems must be in full working order. Should be designed to alert, inform, and guide. That's about the same thing as the other slide, right? Okay. So plan shutdown undertaken in accordance with the procedure, assessment and planning of the impact of the planned shutdown on adjacent plants or shared premises. Well, I think we may have come across that before. If not, what they're saying there is that what you are doing if you are going to take off a tank or a vessel, well, consider the impact of what's going to be connected to that then. Is there like another line connected to that tank? Is there like another unit, right? So you need to consider what's the impact of your shutdown on another plant, another tank, another line, right? Another oil line or whatever have you, right? So all of that is what you consider. All right, plant shutdown can be defined as scheduled shutdown period for a plant for a scheduled maintenance for an expected period of time or an extended period of time. Shutdown provides unique opportunities to a maintenance department not normally available during standard operation or even during short shutdown periods. A large work is required to schedule into a relatively short period of time, right? So this is all about shutdown, the actual process of maintenance then. I don't know if you know, but you all know what shutdown is. It's like the time when the plant will close for changing out valves and oils and catalysts and whatever have you, right? So there isn't too much exam question on the actual process for a shutdown. So I can leave these slides and you can have a read of them, right? They're not going to ask you what is the steps of a shutdown, right? In fact, what I did here, if you look at your book, the book actually didn't really do all of that, right? What we did here, because this is process safety, we do go to plants sometimes. So we kind of make this here more relevant to them. But it's not, I could just really head in for you all, right? So like if you have a planned period of maintenance, you have to plan, well, what work do you want to be carried out? Is it that the tanks have to all be cleaned or drained? Is it that you have to weld, you have to repair, you have to replace catalysts, whatever you're doing then, right? So what is the work which is to be carried out? The bigger step. How are you going to get it done? Shutdown work planning. Do you have to take on contractors? Safeties, which is what they do, right? How much days is it shut down for? Is it for 20 days? Is it for 15 days? Is it for 30 days? The work scheduling, right? This incorporates the development of a schedule, but more importantly, also includes control loops that ensure that the schedule is realistic and achievable. What resources are going to be needed for your shutdown, right? Well, you're taking on more contractors, more safeties. Who's paying for that? Is there a shutdown budget, right? So the planners of a shutdown will have to know, well, we have $5 million to spend on this shutdown. Yes, shutdowns are very expensive. A lot of people get work with that. Periods of maintenance then on a plant is very expensive. The plant goes down, number one, so production isn't running. Then you take on a whole bunch of safeties, a whole bunch of contractors, a whole bunch of welders, a whole bunch of fabricators, laborers. It have to be done though. So shutdown is very expensive for a company. They make the money though, because remember, certain things have to change, right? Seals in a pump have to change. Catalysts in certain industries have to change. Oil have to change in generators. If these things are not done, the plant is going to end up in a catastrophe, right? So I'm sure a lot of us in Trinidad, they have work shut down before. It's long periods of shutdown. It's like 12-hour shifts you are on. Some contractors pay you less than what they are being paid. I mean, the hourly rate is sometimes less. Some pay better than some, right? But the point is here, somebody has planned that. Somebody has given a contract. Those of us in Trinidad would know somebody has given a contract to like Asiquet. Somebody has given a contract, what is it this one? Hanif Mohammed, right? And then they will get the millions and millions of dollars, but then they just take you now at $50 an hour, $60 an hour, etc. Right? But they make a lot of money. Shutdown is a lot of money for all companies, except in the main company itself. But then they do save because remember, if they didn't change these oils and repair these vessels and clean the chimneys and whatever have you, clean the what they call it, the somebody help me. Replace the catalyst. I forget the thing in electrical, right? If we didn't do those things, then the life of those things would have come to an end and the plant would have been in a more worse off condition anyway. So a lot of people, I know a lot of students of mine, after working shutdown, they purchase new cars. Well, probably not new cars, but foreign used cars. And, you make a good 60,000 TT. Those of us in Guyana, that'll be six trees as about 1.8 million Guyanese dollars anyway, right? You make in a short period of time anyway, right? So what I'm saying is that if there's one person making that, imagine all the different safeties and all the fire watch and all the laborers. It's a lot of money. So resource planning, right? Generally, the resources are considered. Let me just leave that one there. Then the other one, shutdown work execution. The project status should be updated continuously. A lot of times, if you all have worked shutdown before, I know some of you all are here and you all are working shutdown, in fact. A lot of the times you find the work finished before time, right? So initially the contract may have said, we doing shutdown for 21 days, but then the work finished in 15 days, or maybe they said it's 30 days you have gotten, but then it finished in 25 days anyway, right? So based on how the project is going, God forbid if they have any accident, that tends to maybe keep back things a bit. But if everything goes according to plan, most shutdown work that I have kind of been associated with, it has kind of finished before, right? So it finished a couple of days before, it finished earlier rather than later anyway, right? So the work extenuation is totally dependent upon the supervisor's skill. And a lot of those managers have good skills to kind of get things done ahead of time anyway. And that's a day for safe startup and shutdown. Tell me if you have any questions. The main thing there I think you have to know is the different types of startup and shutdown. Planned, unplanned, emergency, stage, and delayed, right? All right, those of us in the books, look at page 69. You're going to see some kind of funny looking words here, a lot of strange words here. And there is about 2 to 3 questions right here. We might say today we're going to reach 3.3. If I reach Steam, I was happy. 3.4 is Steam, but we're on 3.3 now, right? Folks, any questions? Let me know. Let me know. Any questions you have? All right. As everything is, I'll read a bit, and then I'm going to have to come off the slide to explain this to you all, right? It's not much enough. But reading is not explanation. But let's read a couple of verses. Not too much slides in a 1, 2, 3, 4, 5, 6, 7, 8. 8 slides. Let's try to read them, right? And I'll explain at the end. But the thing is, there's more than one question here. There's about 4 questions here, right? When I say 4, there's 4 things that they like to test here, right? In that 8 slides anyway. Again, if you are listening, when we had our first class, I told you they will give you a question on what is process safety. They will give you a question on the PDCA cycle. And today you will probably get a question on operating procedures. You would get a question on last 2 weeks class, right? Like hazards and stuff. You will get a question on that. And you are going to get a question on what you're looking at here. I could think of 4 questions here, but I don't know which one will come. My job is to cover all anyway, right? Let's take a read of this slide. I read it first and then I'll explain at the end. A safety critical element, SCE, is classified as an equipment, structure, or system whose failure, so if that piece of equipment fail, could cause or contribute to a major accident. Look at the word, it's safety critical element. So like if that fail, that's the end of it, right? Examples include an emergency shutdown valve. So you're dependent on a valve. You can think of your water tanks. We all have water tanks at home, I guess. So if you have like an emergency, not emergency, like the lock-off valve then, right? If that fails, the tank will start to overflow. So you will hear in the night or you'll hear in the day water flowing. And if this tank is in some place that could flood your house, it could probably flood your basement. But that's just water. Water is, of course, bad in itself. But what about if what is being stored is gasoline? What about if it's oil? What about if it's aviation fuel? So a safety critical element is that sort of unit. If that fails, it's disastrous, right? As if that lock-off valve fail, that thing fail, well, we are going to have a problem anyway, right? You can probably think of it maybe too as you can think of it too as if you're familiar with the fire extinguisher. I just saying, right? If you're familiar with a fire extinguisher, so you pull the fire extinguisher to use and you pull the pin, but the pin doesn't come out. I'm just making up this example, right? I mean, the pin does normally come out, right? I'm just saying, if the pin doesn't come out, the pin has been corroded or something, or maybe it's an defective canister. The pin doesn't come out. So then how could you use the extinguisher? You can't. So in that sense, then the pin there, the pin that prevents, you from squeezing the nozzle is safety critical because if you can't pull out the pin and you can't use the extinguisher could be looking real nice. Could have spent $1,000 TT for it, which is too expensive. But it could have been that. But the thing is, if the pin isn't coming out by some way corroded or welded on there by some manufacturer's defect, nothing can happen, right? So in that sense, that is a safety critical element, right? So examples include emergency shutdown valve, pressure safety valves, or similar valves, right? Safety critical performance standard is systematic management of the identified safety critical element is a continuous process ensuring the safety barriers are in place and effective in alignment with the specific performance standards. I'll move on, that's just words, right? A performance standard is typically defined as a set of requirements that constitutes the basis for assurance tasks for safety critical elements during design and operation. This performance is required in order to manage the major accident hazards. Asset owners may have a set of generic performance standards available. I'll come back and explain this one. This one has a question in it, right? Same heading, right? Project or asset-specific performance standards are developed during the design phase and are based on the generic performance standards. The asset, which would be your equipment, the asset is your valve or whatever, right? Your locker valves or whatever, right? Specific performance standards reflect the design of installation, local rules and regulation, as well as multiple other considerations of asset operation standpoint. Possible areas of concern is that the performance standards of design phases are too generic. They are limited, no use in connection with test and maintenance. Performance standards are not validated, containing wrong, misleading information. Performance standards developed without taking the operation input into consideration doesn't fit into the organization or the existing test and maintenance system. I'll explain all of this in a bit. Let's try to read out this slide, right? Examples of safety performance standards, right? So safety critical backlog, example backlog of maintenance which are deemed critical to the safety of the plant. Temporary repairs, level of deferred maintenance, the number of safety instrumented systems that have been inhibited or inhibits, overrides in use on the control panel, the percent of equipment within 10% of the corrosion limit, the percent of maintenance not completed on time. Okay, so let's take it back a bit. So what I'll do for this, I'll write it on the left-hand side. And if you want to write, I'll just break it down for you. Right? I'll just break it down for you. Now we have one more to go. So let's try to get this one out of the way, right? So the first thing you want to know here, let's grab my marker a bit. And I said it before, right? But at least about 3 of them all in one. Let's go over this marker now. Marker isn't marking. Okay, so the first thing you want to know is what is a safety critical element? SCE, right? And we said this before, so this is kind of okay on this slide. A safety critical element is that piece of equipment that if it fails, the rest of the equipment isn't good. Well, it could lead to like a disaster, right? So if you want to picture, I don't want to draw it, if you want to picture like a tank, even a water tank at home would have like a locker valve, right? And so like if that shutter valve on your line then, right? Well, actually the shutter valve is, well, you can have an automatic shutter valve, but most of your tanks have a float, right? So if the float on the tank doesn't work then, well, then the tank could overflow. So you can think of the float, putting float here, right? You can think of the float on your water tanks at home. But the thing is, every equipment have a piece of it that could be said to be safety critical, right? So like the electric heater at home, right? What would be the safety critical part of the electric heater at home? Think of the shower, if you're going to take a shower. So those of us, some of us could think about the electric heater, some of us could think of the shower, right? What would be the safety critical part of the shower? That if that fails, well, you wouldn't get a hot bath then. Everything in life, every piece of equipment man have a safety critical piece in it then. What would it be for the electric heater? Quickly, folks, quickly. Adisa, Mary, Quincy, Roger,
Sorry, that
Steffi.
one for the hot shower.
Yeah.
The safety, the critical part would be the electricity that you're getting. So I'm thinking that would be the fuse box.
Okay, the fuse box. Okay. I think there is something called the heating element. I'm not too familiar with them, right? But I know there's something in the shower head, or if you
The
have
coil
like
you're speaking about?
yeah, yeah. So if you have like a central heating unit, I don't know if you all have like a central heating, like a central heating unit to your house that you just have the heating element on your shower, but you know there's a heating element inside it that if you turn it, it'll go from hot to cold. So if the heating element doesn't work, then what I'm saying, you could have water, you could have electricity, but if the heating element doesn't work, well, then the heating element is what is safety critical because you're trying to get a hot bath and you wouldn't be able to because the heating element doesn't work, right? Well, maybe I should change the example. What about your phone? What do you think in a phone is a safety critical element? What do you think in your phone could be a safety critical element? It could have more than one, so that's the thing, right? What in your phone could be a safety critical element?
That will be my charging port.
The charging port, very good, right? So the battery. So it doesn't matter if you have the best data plan, doesn't matter if you have, like a cheaper phone or an expensive phone. But if it's not holding charge, well, then nothing could work. And for some people too, maybe the Wi-Fi facility, right? Wi-Fi, this is just, it could have more than one, like the Wi-Fi functions. They have a really good phone, but you're not picking up Wi-Fi. There's something manufacturally, well, in terms of the manufacturing defect with the phone then, right? But I do agree the battery, the charging, both these things could be defined as a safety critical element. You understand the thing? That if these things fail, then the thing ain't no good. Like the
Sir,
battery, yeah, go ahead.
for the phone, right? The safety critical element for that phone, from most Androids anyway, like Samsung, would be the wireless charging pad. Apparently, if that goes bad, it doesn't matter if your battery is good or your charging port is good. But if
That's,
that particular
oh,
charging pad goes bad, your phone will
right.
not charge, will not come on, will not do anything for you.
Okay, very good. Thanks for the information. So, I mean, you get to the point. So you understand the point that, I mean, it could be a tank, it could be your car, it could be your phone, but everything that have something that if that goes bad, I have a headphone here. I mean, as much as it looks, if something goes bad with this, with the volume or whatever, then as good as it looks, right? Or as good it doesn't look, it ain't no good, right? So everything have that piece of it that's called a safety critical element. Okay, next thing. So if you understand that next thing, right here, the next thing is this. Now, this is, remember, I tell you, you have three questions here, right? 3 to 4 questions. And the next thing is this, right? Every safety critical element performs to standard. So that's what you see in here. If you could understand the heading now, safety critical performance standard. Everything you see that have a limit, right? Everything have a limit. It have something in this, something in it. And that's why they have the shutdown too, because they may know like the life of a plant or the life of our equipment, the oil then has to change because it's coming to the end of the life of that generator. The oil has to change or the seals have to change, right? So safety critical element perform to a standard. So I want to see if you understand this. Safety critical element performs to a limit that they are not Superman, right? I mean, like I'm trying to think of I guess I'm trying to think of a food, right? So like, like well, as much as you charge it, I mean, the battery has a life, right? It may give you 12 hours of use based on if you're using, continuous videos or if you're on Bluetooth, right? But it have a capacity then. So you think you understand everything has a limit there, and that's called the performance standard. It will perform to that standard only, right? So if I get back to my tank example here, or a vessel, if this vessel would have been pressurized to a certain PSI, or the tank has a certain capacity, it cannot hold more than that then. That's the performance standard of the tank, right? A tank has to be welded, right? So they're going to put some welded joints here. So if they had done this well on the tank and they said the tank would actually hold, 1,000 barrels or whatever have you of oil, the welded joints have been tested to that. That's the performance standard of the tank, which in this case could be seen as a safety critical element, right? You think you understand that a bit? So all safety critical element is not Superman, right? They just wouldn't keep on functioning. They perform to a standard. So all safety critical element functions only to a standard. Think you get that a bit? Let me know if you get that one. I'll try to use some other examples if you want. Tell me if you get it. If not, I'll move on because it's not that hard. It's just that all safety critical element would not, be indestructible then. They have a standard that if you pass that standard, they would probably deteriorate, right? Like your battery, if you have it left on, if you have using your phone, you have your phone plugged on, it's heating up, right? You have a whole set of stuff running in it. Well, it's going to perform to a certain standard. Eventually, you may find that your phone running low. They like when you press, you have to, it's probably running a bit slow. I was going to say slower, not low, but it's running slower because you have passed the performance standard in it, right? You have passed the amount of, you could probably think of it like data. If you buy data then, right? You purchase data for your devices, but you have exceeded the amount, you have passed the amount, so then you can't get your data again. So every safety critical element then performs to a performance standard. Tell me if you're okay with that. And we go in again with the next one. You all didn't really say anything, huh?
Yes, sir. I
Okay, good.
understand as
Okay,
well.
good.
Like
You could just think of it, yeah, just think of it like, I mean, sometimes you put on a headphone, right? But this will only give you a certain amount of decibels. So if you want louder sound than that, you probably have to get a headphones that would give a louder sound, or you play it on a louder speaker. But this wouldn't play hard then as, like main speakers, right? So this performs to the standard to which it has been designed. You wouldn't expect to put on this and have a party because nobody would hear you unless if you have Bluetooth. But the thing is, it performs the performance standard. Okay, here the next question here, right? And I wanted to look on page 69. Um, so I just have to get it because I'm looking at the time and there's 3 and 4. There's 2 questions here still to go. So they could ask, so what is a safety critical element? It's that piece of the equipment. If it fails, the whole thing goes bad. Safety critical equipment performs to a certain standard. So that may be a question. It performs a performance standard. But here the next question, right? The next question is, how do they determine that standard? How is it that the manufacturers or the developers or the designers of the tank or the food, how is it they know that the battery is good for 12 hours? How do they know the tank could withstand 1,000, gallons of oil or whatever have you? How do they know that, right? So the answer is with testing. However, there's a particular answer NEBOSH is looking for. So here what, I'm going to write it here. So safety critical element, please, just for the write is better than this, right? Safety critical element performs to a performance standard. So we said that already. It performs to a performance standard, but how they determine the standard? There's actually a couple of ways, but the one NEBOSH is looking for is something called a process hazard analysis, a PHA. Please take a note of this. So you can find that if you want, if you have the book, I'm going to read to the bottom of page 69, left-hand side. I'll read the last paragraph for you now, right? So it says this: these performance standards should be established for all the safety critical elements and for the equipment included, both individual items and group items. Example, emergency shutdown. So they said every safety critical element must have a performance standard, but we need to determine what it is. So the last line, if you have a book, tell me if you see in page 69, left-hand side, the last line have about 3 answers, but remember, there's only one you have to give. So one of these ways is the best way. So listen to what they said. It says some of the elements may be derived from accepted external standards. Let me just admit a student there. So some ways to determine the performance standards is to look like at a manufacturer's instruction then, right? From accepted external standards, example, fire protective coating for structures and metal thickness for tanks. The last line said, others will be derived from an analysis of the design through what? What is the last 3 words you see in there? Through what? Those of us in the book. Through
process
The
the
hazard.
process hazard analysis.
process hazard analysis. So that's why I write it there, right? So please remember these things are common questions. Once you listen, it just be an easy question. A lot of students just look for it and they get it correct. There's only one more we have to go now. This one is less common, but it does come too, right? Every paper is different. PHA is probably the most common question, right? All right, so for this one, I want you to watch your book. You may have to turn the page, but it begins on page 69. But if you turn the page, you'll see it on page 70, 71. I'll read it for you. It's on my slide too, but as I write it, I feel I'll continue writing, right? And I'll just tell you what it is, right? So let's try to understand first. If you want, just watch the book a bit. On page 69, they mentioned something called, on page 69, relevance of the elements of something called FASI. I'm trying to get this slide to move. If this slide move, you'll see it on this slide too, right? If it doesn't move, well, you'll have to just take it from the book or take it from the slide, right? There's something called FASI. FASI, right? So what is this? What is FASI, right? Let's see what the book says. The book says FASI is a model for performance standards, which can be described in terms of its functionality. What does it mean in a FASI, right? Look at there, functionality, availability. Look at it on the slide. If you want to turn the book, you can see it when you turn the book. Functionality, availability, right? Reliability. I'm looking on page 70 here. Survivability, interdependency. But the question is, what does that have to do with anything, right? What is these things now, right? Well, listen to it. Listen how simple it is, right? Listen to how simple it is. Tell me when you're ready to listen how simple it is, right? Now, I'll do the explanation and I'll tell you what you have asked before for the exam then, right? But let's do the explanation first, right? But to get the explanation, I'm going back to number one, because you see, all of this is one. All of this, these are not separate. FASI is not FASI by itself. FASI is a part of everything that you're looking at here. Let's take it back to step one on this slide and explain everything again, right? I'll just tie in FASI for you. So the point is here, all man-made equipment, tank, vessel, rod, phone, cars, everything have something in it that if that fail, the whole system fail. It really makes sense. Your car wouldn't move then if the alternator ain't charging the battery and your battery dead, right? So, there is a piece of it. And there are many safety critical elements. It doesn't have to be just one, right? So we cover that. Tell me if you're okay with that. Everybody okay with that point? Come, don't fall asleep now. Next thing.
Yes, sir.
Okay,
Yes.
next thing. All safety critical element perform to like a standard now. It just wouldn't just keep on going. Everything have a limit. The battery in your phone, you probably plug it on, you probably notice that every 12 hours this thing had a charge, right? Same thing for a tank. And I told you that's why they do shutdowns. That's why they may realize, okay, this tank, but it have corrosion, or this tank, the seals in it had a change, or this pump, the seals had a change, the oil had a change, right? So everything have a performance standard. It just wouldn't keep on going, right? So how do we determine the performance standard? The best answer, according to NIBOSH, is a process hazard analysis, right? You can take the manufacturer's instruction, but please remember they're looking for this answer here. So the last thing now is this. What is FASI? But from what we saw in the book, FASI is something to do with the SCE. FASI is something to do with your piece of equipment. FASI is something to do with your phone. FASI is not FASI by itself. If you go back to page 69, FASI is a model for performance standard. And performance standards are what your SCE perform to. So FASI have to do with every piece of equipment that you have. So listen to what FASI is. Let me give you the explanation, all right? FASI is this. FASI is like the characteristic of that safety critical element. Is like the characteristic of it. Like if you're relying on your charging port to charge your phone, well, it must be functional there, right? So all safety critical element must have, if you read this up here, right? The safety critical element must have these characteristics. They must be functional. If you want, I could change the example now. I'm just finish the phone example and I'll change the example, right? But it must be functional. It must be available. It must be reliable. It must be survivable. And if there's other apps or other things that is dependent on the charging port, it must be interdependent. Maybe the phone is not the best example, as it's not process safety anyway, right? But if we could think about, let's think about, God forbid, a fire. Let's think about a fire in a company, right? So in a company, they may have, in the event of a fire, they may have a smoke detector, right? Now that smoke detector may be linked into an alarm, and then that alarm may be linked into a fire suppressing unit, right? So I'll double back with this here. This is just the wiring anywhere, and put the fire suppressing unit there, right? So in the event of a fire, we can say the smoke detector is the what? The safety critical element, because this is going to warn the building. Think of an offshore platform. In that sense, then it's very critical, right? So the smoke detector is going to be the safety critical element, right? And in the event of a fire, it must have the characteristic, it must function. You understand? You are dependent on it then. That's why it's safety critical. It must function. It must be available. It must be reliable. That smoke detector, this alarm, this sprinkler system must survive some elements of the fire. I don't know if you know that. There's a special wiring they use. It's called Pirelli, but it's Pirelli cables. I'm not too sure the code on it now. I can't remember the code on the Pirelli fibers on it, but they have some wires that can withstand fire then, right? So in the event of a fire, the first thing to burn out must not be what you're relying on. If this is a sprinkler system, this is a sprinkler system, right? This must not be the first thing that burns out. This must survive some elements of the heat and smoke, right? And as I drew here, if the alarm is interdependent on the smoke detector, well, this must survive for the alarm to go off. When the alarm goes off, the alarm must not suddenly melt away, but it must survive, and it's interdependent into the sprinkler system. Think you understand that a bit? That the elements of the safety critical element must have these characteristics. It must be functional, available, reliable, survivable, and interdependent. Tell me what you think. If you don't like this example, I'll use another one. Let me just use a backup generator, right? So you are in your hotel, like me. Well, it was last week, right? And power is known to go, power outages are very common in Guyana, right? So you are there, the safety critical element, let's just say it's the generator, right? So it's the generator that they have. I'll just put a G here. The generator that they have is the safety critical element, right? So in the event of a power failure, now the generator will push out how much, amps or whatever. So that's the performance standard. They would have determined that, how much voltage, right? But I say amps, but it's really voltage, right? Generators normally produce voltage, and then that is converted back into the current anyway, right? So the generator is there, but in the event of a power failure, it must be functional. You understand this, folks? If there's a power failure, then the generator must kick in then, right? It cannot be the power goes and they say, well, shouldn't the generator have come on? Well, it should, it must be functional. So the safety critical element in this case is the generator. So it must be functional, it must be available, it must be reliable. If you have tested that generator for 24 hours, right? If the generator kicks on, it shouldn't stop producing power after 10 minutes. In that case, it's not reliable. You understand when I said FASI is the characteristics of the SCE? To be an SCE, then you must have these characteristics. The components must function, they must charge, they must be available, they must be reliable, they must survive. And if there's anything dependent on it, it must be linked to that, and it is interdependent. Tell me what you think, right? So the generator should survive. If it's something else, maybe linked to this, maybe a humidifier linked to the generator, or something linked to the hotel, maybe water supply, the power, of course, but then maybe it's linked to the generator, to the pumps for the hotel to get water, right? So that if the water pump is connected to that power supply as well, it must be interdependent, which shows those features anyway. So if you understand it, now the thing is, they wouldn't really ask the explanation, but I had to do the explanation for you to understand that FASI is not a thing then. FASI is the characteristics of the SCE, right? And just to the exam question, as we are 2 minutes to go. So for the exam question, I try to make up the last minute. they sometimes ask, what is the meaning of fussy? What that means then is that you have to learn these words. Yes, you have to learn the words. You have to learn the words functional, or functionality, availability, reliability, survivability, and interdependency, because they will switch it with you. Remember, it's multiple choice. I can show you questions, right? They will switch a word. So you have to learn this by heart. Functional, available, reliable. They may put sustainable, and sustainable will be wrong, right? So yeah, it's really survivable and not sustainable. So you have to learn the meaning of fussy, right? It's in your book there, page 17. It's also looking at you here, so we can have a look at it and try to start to commit these things to your head from now. I was telling you now, some of my students, when they pass and you'll receive your certs and stuff, some people still say, we still remember what FASI is, but I can't remember what it stands for. A lot of people forget as years go by, but they still remember the acronym FASI, F-A-R-S-I anyway. Tell me if you understand it. We are officially done there for today. And the very next slide, I did mention to you all, look at that, I did mention to you all that we would not have reached STEAM. And I know that because of how powerful this page is, page 69, 70, 71, have a lot of exam questions on it. So even though it looked like just one page, it took us a half an hour, right? As I say, like I was doubtful that we would have reached STEAM. And if we had reached STEAM, I would have been happy. But we reached it, but we didn't get to read anything in it anyway, right? Folks, that's a wrap. Let me stop the recording. I actually had two classes today back to back. So